Yes, hello, hi, welcome. I welcome all of you to the wonderful journey called EDUHUNT IIT and NEET Foundation Program. This is Sukumar, your chemistry mentor. With this particular video, I am going to start 7th class foundation chemistry. I am going to start with the module 1 and the particular chapter name is types of chemical reactions. Types of chemical reactions. So let me introduce this first to you. First of all, I hope all of you know. First of all, I hope all of you know what is chemistry. First of all, what is chemistry? So you all know, you know the definition, sir. We know, sir. We already studied this in 6th class, sir, or in 5th class, sir. Yes, chemistry is the chemistry. Yes, let me start from the very basic. Okay, chemistry is the study of matter. Study of matter. Fine. That's enough. But there is another way of defining what is chemistry. Okay, there is another way of defining what is chemistry by extending this. Chemistry is the study of matter and its interaction with its surroundings. Chemistry is the study of matter and its interaction with its surroundings. Okay. So what is chemistry? Chemistry is the study of matter, sir, and how that matter is interacting with its surrounding matter. Okay, see, if you look carefully, everything around you, including your body, including you and me, everything is matter, because you know the fundamental definition of matter. Matter is something which has mass and occupies some space. So your body has mass, it is occupying some space. Your book, your pen, your college, your school, everything around you which is having some mass and occupying some space is matter. Okay, sir, we learned that in previous class, sir. Yes, study of matter. Okay, but how that matter is interacting with its surrounding matter. Okay, that interaction. Now in this particular chapter we are going to focus on how the matter is interacting with its surrounding matter, and that comes under the category called types chemical reaction. A chemical reaction is nothing but how matter is interacting with its surrounding matter. But the particular matter we are dealing with can be a molecule or ion or atom, anything. Okay, yes. So the point here is, for suppose I am taking a chemical species, okay, one chemical species, two chemical species, two or more chemical species. Okay, a chemical species I am taking, let us say A is a chemical species interacting with B chemical species. You can take more than two chemical species. Okay, now these two are chemical species. Sir, what you mean by chemical species, sir? Yes, what I mean by chemical species is these chemical species can be atom or molecule or ion, etc. That can be molecule or atom, ion. Fine. I hope you know what is molecule, what is atom, what is ion. Shall I give you example? What is an example for atom? For suppose let's take chlorine atom. Or let me take an example, sulfur atom. Molecule, H2O molecule. Ion, Na plus ion or NH4 plus ion or Na plus ion or Cl minus ion. So the point is, a chemical species can be atom or molecule or ion interacting with other chemical species. It is having some interaction. It is okay. Why it is interacting? It is interacting to give another set of chemical species. That can be one chemical species or more than one chemical species. More than 1, 2, 3, 4 or any. So the point is, this is a different set of chemical species. That is a different set of chemical species. These chemical species interacting among them to give another set of chemical species. So this particular process is called chemical reaction. Okay. This particular process happening in our real life. This particular process when takes place in our real life, it is called chemical reaction. And when you represent that chemical reaction on paper like this, is called chemical equation. So let me try to differentiate fundamentally between what is chemical reaction, what is chemical equation. See, when a particular matter interacts with other matter to give separate matter, different matter, that is chemical reaction that happens in reality, real life. But when you represent that reaction on paper with the symbols like this, that is called chemical equation. So what you can see fundamentally in a chemical equation, there is an arrow mark. This arrow mark is indicating this chemical species are converting into this chemical species. Yes. So to the left side you are having different set of chemical species, and to the right side you are having different set of chemical species. Now these chemical species are particularly called as reactants. Sometimes we use the name called reagents. Instead of using the word reactants, we use the name called reagents. So simply, there are reagents. There is in a chemical equation. There is an arrow mark. Towards left side of the arrow mark there is reactants, and towards right side there is products. Yes. So simply, what happens in a chemical reaction? In a chemical reaction, reactants converted to products. Simple, na? In a chemical reaction, reactants converted to products. So there are so many chemical reactions happening in our daily life. We can observe them, but we can't observe them at a micro level. The point is, see, there is a chemical change happening in our daily life. For example, rusting of iron. If you keep any iron material outside for a sufficient time, there happens rusting. Actually, rusting is a chemical process. Okay, you can observe the rust, the kind of rust formed on the iron surface after its formation. But what happening there at micro level, you can't see with our naked eye. Similarly, souring of milk, fermentation of grapes, cooking of food. Okay, you can observe you can observe cooking of food, but you can't observe what happening at a micro level, right? Cooking of food and the digestion of that food inside our body, everything is a chemical process, chemical reaction. But if you represent that chemical reaction on paper, you need to follow some procedure like arrow mark. To the left side of the arrow mark, the chemical species which are interacting with each other we have taken called reactants, and towards the right side of the arrow mark, the chemical species which are newly formed called products. So simply, a chemical reaction is a process in which one chemical species, one particular type of chemical species converted to another particular type of chemical species. Because these products are entirely, the properties of these products are entirely different from the reactants. Okay, so you may get questions, sir, you said that, you may get a doubt like that. Yes, sir, you said that these chemical species are interacting with each other. These chemical species are interacting with each other to give different chemical species. Okay, fine, sir. Sir, what type of interaction is that, sir? In that interaction, how they interact, sir? Do they talk to each other? No. In interaction means, fundamentally what happens in interaction here is, see, if I take one atom, it's different, but if it is a molecule or ion, you know, in molecule or ion there are group of atoms. In molecule or ion there are group of atoms. How the group of atoms are connected? By chemical bonds. So in reactants there is some existing chemical bonds. In reactants there is some existing chemical bonds, chemical bond already present. So to convert this chemical species into another chemical species, you have to break the existing bond. You need to break the existing bond and form a new type of bond. So fundamentally in any chemical reaction what happens is bond breaking, bond making. There is the breaking of existing bonds and the formation of new bonds. Let me explain with a particular real example. See, because this is a somewhat it's a dummy example, I used A and B. Let me take a particular chemical species for the example purpose. For suppose if I take a chemical reaction between H2 molecule, you know very well, hydrogen element, matter, plus iodine molecule, iodine element. Okay, and what happens when this particular matter interacts with this particular matter? Interaction means they come close together, they contact. Okay, and something happens there at micro level, so that we can't see with the naked eye. Our eye can't watch that level, that micro level things. Okay, but something is definitely happening, because when they interact with each other, you are getting completely different matter, that is HI. Okay. So you know very well, first you need to balance it, right? Two hydrogen atoms are present. Yes, I'll write 2 here, fine. Okay, see, to balance the chemical reaction, what I did here, see, in the subscript, in the hydrogen molecule there is a subscript telling in H2 there is 2 atoms. Okay, but here in HI, to represent the same number of hydrogen atoms, I used this coefficient 2, right? Yes, similarly. So 2 iodine is there, 2 into I, 2 iodine. 2 hydrogen atoms are present, 2 H atoms. Now fine. Now H2 interacts with I2 to give 2 HI. Fine. Now the point is, what happened here? There is something happened between these 2 chemical species to convert into a particular different chemical species. So what I am telling to convey here is the properties of H2, the properties of I2 are entirely different from the properties of HI. Chemically, HI is entirely different. So what happens, sir? Yes, if you get into the bond structure of these chemical species, hydrogen, there is between two hydrogen atoms there is a chemical bond, and similarly iodine, between two I atoms there is a chemical bond. Okay, yes, between them I am taking plus H2 plus I2. Okay, now making an arrow mark. Now leaving to your imagination, there is something happening here. To give a particular compound HI. Okay, now you guess something. What happened here? See, if there is no bond breaking here, then how can there will be a new bond between H and I? Initially, H bonded to H, I bonded to I. So these are the existing bonds now. H bond, I bond, these are existing bonds, and this is a new bond. So for the formation of new bond between H and I, you must break existing bond between HH and II. Then how can I represent that on paper? Now try to make slowly the bond is breaking. So I am representing like this. Slowly this bond is breaking. Iodine. Slowly this bond is breaking. And simultaneously there is a new bond formation between this and. So completely what happens? So simultaneously what happens? There is a new bond formation between H and I. So the point is in a chemical reaction there is very fundamental point, that is there is bond breaking and bond making. Okay? Yes. Shall I give you one more example for a chemical reaction? Yes. See, if I take a magnesium ribbon. Sir, what is magnesium ribbon, sir? It's simply a small strip of magnesium. Okay, it is available. Small strip of magnesium, you take small strip of magnesium and heat it. Now, see, heating something in general is nothing but combustion. That means heating something means reaction with oxygen. Okay, that means when you take a magnesium ribbon and heat it, that means you interact with oxygen. What happens and what we can observe physically is there is a brilliant dazzling light. It burns with a brilliant dazzling flame. Okay, and a different compound is formed called magnesium oxide. Okay, so this is what happened actually. Okay, so as I told previously, when there is a chemical reaction, there are something which we can observe with the naked eye. We can feel, we can observe some properties like there are some kind of coloration you can observe, some kind of color change you can observe, some kind of precipitate formation you can notice, some kind of gas evolution you can notice. So these are the characteristics of chemical reaction we can observe. But what we can't observe with the naked eye is the bond breaking, bond making, the micro level things happening between the chemical species. Okay, see, so this is the chemical reaction happened in reality. The chemical reaction, what happened you observed in reality? You have taken a magnesium ribbon. Really, you have taken magnesium ribbon and you burned that magnesium ribbon in flame, and that burns with a dazzling brilliance, white color flame. Okay, that's the reality you can observe. Okay, so what happened in that process? In that process, a new chemical compound formed called magnesium oxide. See, in this entire process, there are something you can notice with the naked eye and something you can't notice with the naked eye. What is this? So the color change you can observe. The dazzling, brilliant flame you can observe. If there is some evolution of gas, you can observe. If there is any formation of white color substance, you can observe. Yes, but what you can't observe is the fundamental bond breaking and bond making. Yes, this is magnesium oxide, a white colored powder. You can observe a white powder. White powder. Okay, so this is the chemical reaction. This is the chemical reaction actually happened, and the way to represent this chemical reaction on paper is take magnesium element symbol, okay, and interact that, take oxygen symbol O2 and make an arrow mark like this, and you must know what is the formula for magnesium oxide, MgO. Okay, now try to balance this. There is 2 oxygen and you must show 2 oxygens on product side also. For that, use the coefficient 2 here. In that process, there is 2 magnesium. Okay, so to show that magnesium, two magnesium atoms here, I am writing coefficient 2 here. So it is balanced. This is the way of balancing. But the point is here, magnesium burned in oxygen to give magnesium oxide. So this is chemical equation. So the chemical equation represents actual chemical reaction. Okay, yes, as I told previously, in a chemical reaction there are some characteristics we can observe. See, chemical reaction, see, if some chemical reaction is happening, I told you that you can't observe what happens, which bond breaks, how the bond breaks, that micro level things we can't notice. But we can observe some characteristics of reaction. By the help of that characteristics only, we can realize that chemical reaction happened. Otherwise, we don't know what happened. So let me take a real examples to explain the characteristics of chemical reaction with the help of which we can conclude that reaction happened or not. Yes, characteristics of chemical reactions. So when the chemical reaction takes place, we can observe some characteristic changes. When chemical reaction takes place, we can observe some characteristic changes. Okay, of course, I told you previously several times, of course, we can't notice with the naked eye how bond breaks, how new bond forms, that level of micro level things we can't notice. Okay, we study later, but the point is when chemical reaction takes place, there is a confirmatory observations. We can simply observe some physical changes, okay, characteristic changes, with the help of which we can say the reaction is happened or not. Okay, yes, see how, for suppose I'll take a test tube. Okay, I'll take a test tube. In this test tube, I have taken HCl acid, you know, hydrochloric acid solution. That means I have taken water, inside water I dissolve HCl, but it's almost transparent, almost looks like water only, some fumes are coming, that's it. So transparent, nothing visible. Okay, everything transparent, so nothing visible chemical, anything. Okay, just like water with some fumes, fine. Now you add zinc granules into it, some zinc granule, ZNS, zinc granules, small pieces of zinc. Okay, now what you do here, you have taken two chemical species, a matter and different matter, two chemical species interaction, because now they are in contact, they are going to interact. Okay, But the point is, how you can notice or how you confirm there is an interaction between them? There isn't. See, because at micro level what happens, zinc is giving electrons, hydrogen is taking electrons, those things you can't notice with the naked eye, na? So what is the confirmatory observation so that we can say zinc and HCl are interacting? Yes. In this particular example, what happens is, after you add zinc to the HCl, immediately after few seconds, what happens? There is evolution of some gas. There is evolution of some gas. Okay, now if you think carefully, what happens? Yes, now try to represent that process here. This is the actual reaction happening in our real life, in front of you. But now we are going to represent this process on paper. How? You have taken zinc plus you interacted that zinc with HCl. Now what is the possibility? What is the possibility? Yes, when zinc reacts with HCl, the point is, the very fundamental point is, HCl, you know, HCl is an acid which breaks like H plus and Cl minus. Okay, and what this zinc will do? Zinc will give electrons, Zn2 plus, giving 2 electrons. Now the point is, when you take 2 HCl, because see, think about the number of positive species and negative species. Here 2 electrons, 2 negative particles, 1 positive particle. So you take 2 HCl, so that 2H plus, 2Cl minus. Okay, now 2H plus, 2 electrons. So if you take 1H plus, it will take 1 electron, you will get 1 H atom. Similarly, when you take 2H plus, supplied 2 electrons, you will get that H2 gas. The point here is, when zinc reacts with HCl, you will get hydrogen gas liberated and left with 2 Cl minus. Now what happens to this Cl minus? This is Cl minus and Zn2 plus. These two will combine to give a byproduct ZnCl2. See, this is the real thing happened in front of you. You did by your own. And you represented that process on paper like this. This is chemical reaction and this is the chemical equation. Okay, but what is the characteristic property with which you observed this reaction or you confirmed this reaction, whether it happened or not? The evolution of gas. Evolution of gas. Like this, there are some characteristic properties with the help of which we can observe whether the reaction is happening or not, like this evolution of gas, or in some reactions there is a characteristic color change also. So when you start the reaction and you wait for the color change, so when the color change happens, you can realize that yes, reaction is happening. And in some chemical reactions there is a characteristic compound formation. You can observe some kind of precipitate, some kind of substance formed in the solution. Let me explain. Let me explain with an example. When you take a barium chloride solution, it is a white color solution, okay, aqueous solution, barium chloride, and treat that barium chloride with H2SO4 acid, H2SO4, sulfuric acid solution. So two clear solutions, sulfuric acid liquid state solution, barium chloride white color solution. But when you add slowly, when you add barium chloride to sulfuric acid or sulfuric acid to barium chloride, slowly drop by drop, in the resultant solution, you can observe a white color precipitate formed, a white color substance settled at the bottom or getting to the bottom. You can notice some kind of white color precipitate formation. Now try to explain what happened between them, what happened between these two. The point is, First of all, this is a solution and that is a solution, and you can't notice anything at micro level. There are two solutions. You added one solution slowly to the other solution. But what is the confirmatory characteristic observation so that you can say these two interacted? Yes, by the precipitate formation. So with the help of that precipitate formation, with the help of that characteristic property, the formation of precipitate, you can say there is a chemical reaction between them. Yes. And what happened between them? BaCl2 plus H2SO4 gives rise to what? Now let us break down that. BaCl2, it gives two kinds of radical, Ba2 plus 2Cl minus. Similarly, H2SO4. H2SO4 gives rise to 2H plus and 1 SO4, 2 negative. SO4, 2 negative. Now point is, now try to add the cation of this with the anion of that. Cation of this with the anion of that. That means HCl, 2 HCl you expect. Yes. And rest, cation of this with the anion of that. BaSO4. BaSO4, barium sulfate. But the point is, the solubility of barium sulfate is very less in water. That's why this barium sulfate will be present as a solid form in water, which is nothing but the precipitate. The substance, when not able to dissolve in water, it will remain as a solid inside the liquid medium. So we call that solid inside that liquid medium as a precipitate. Okay, I hope you understand this. In the next video, we are going to discuss what are the types of chemical reactions. Thank you.